Hello, this is Dr. Grande. Welcome to my video on reliability and validity in appraisal. So these are two important constructs that are often difficult to understand. So I wanted to make this separate video to explain specifically these concepts and how they relate to appraisal. First, let's take a look at reliability. So what reliability means is, does the measure, meaning the instrument or the assessment you're going to use, does the measure provide stable, dependable, and consistent results? This is unrelated to the usefulness of the results, which is to say that reliability a reliable instrument isn't automatically valid. Now, I'll talk about validity in a while. Validity has to do with the accuracy of an instrument, but reliability only has to do with the consistency. So an example might be a scale. So if a scale is designed to measure weight and it's off by 10 pounds, so every time an individual steps on the scale, it's always going to be off by those 10 pounds. It's not going to be valid because the weight's incorrect, but it will be consistent. It'll always be different than the true weight by the same amount. So you can think about reliability in terms of observed score. Right? Observed score is equivalent to the true score plus measurement error. And true score is a construct that we really can't figure out directly. So let's look at an abstract concept like intelligence. Well, every individual has a true score of intelligence, but we don't know what that is. We can't measure that directly. Intelligence is an extremely complex construct. But we try to measure it because measuring intelligence can be useful for certain purposes. So we have a score that a participant receives on an intelligence test, and we know that's equivalent to their true score plus the measurement error. So let's take a look at the reliability coefficient. Right? Reliability coefficient is the variance of the true score divided by the variance of the observed score. Now you might remember I just said that we can't directly observe the true score, so we know that the reliability coefficient is a construct or is a value which we won't really ever know for an instrument, but we can estimate it. So what we do is we estimate the reliability coefficient. The reliability coefficient itself is a value between 0 and 1. And it's fairly easy to interpret. For example, a coefficient of 0.96 tells us that 96% of the score variability in a group of participants is explained by true score differences. And 4% of that score variability is due to measurement error. Now it's important to note that when dealing with statistics, it's not uncommon for a lot of different coefficients that we work with to be squared. The reliability coefficient is not squared. So if you have a reliability coefficient of 0.8, it would explain 80%, right? Or 80% of the score variability would be explained by true score, not 0.64, which is the square of 0.8. It would actually be 80%, so it's interpreted directly. So 0.96, 96%. It's very straightforward. So let's look at some of the methods we use to determine reliability. One method is called test-retest. So this is when the same test is given to the same group, but on two different occasions, 2 different times. This is a good method if the instrument measures a relatively stable characteristic, one that we don't expect will change over time. For example, intelligence. Potentially unstable characteristics would be something like mood. And the test-retest method would not be recommended for examining the reliability or determining or estimating the reliability of an instrument designed to measure mood. It's also not appropriate when scores are affected by repeated measurement. Practice and memory effects may contribute to error if they affect clients in different ways. If they affect the clients in the same ways, then it won't contribute to error. But if it affects the clients in different ways, then it can. And there's a time effect as well. Changes in clients can occur between the two administrations, since we're administering the instrument at two different points in time. Another way to estimate reliability is called alternate forms reliability. This is when you have the same group and they're given two equivalent forms of the measure. It may or may not be administered at different times. If it is administered at different times, it can contribute to error, just like in the test-retest example. Similar to the test-retest method, it's appropriate for stable characteristics and not appropriate when scores are affected by repeated measurement. Another way we can estimate reliability is looking at internal consistency. I'm going to review three different types of internal consistency. One is the split half method. One way to determine internal consistency is the split half method. This is where you split an instrument in half so that each client generates two scores. They take two instruments. There's a lot of ways to split an instrument in half, but the most common method is to take the odd items and put them on one instrument and the even items and put them on another. Now there's a problem with this method. When you have a lower number of items, that decreases reliability. And there is a formula called the Spearman-Brown prediction formula, which is used to compensate for the effect of the split half method. Now when you're dealing with dichotomous variables, right, or dichotomous items, so these are items, for example, they'll be answered true or false. There's a method called KR20, so that's for use with dichotomous responses. And there's another method called Cronbach's alpha, which is a formula used to calculate inter-item consistency. Interrater consistency. This is a little bit different than the methods that we've been looking at up to this point. This is where you have two or more raters, usually experts or individuals specially trained to rate. And a calculation of some sort of correlation coefficient is used, so they'll each rate different measures, and somebody, a researcher, usually will look at this calculation, this correlation coefficient, and see how strongly the two raters correlated. Or they'll look at the percentage of agreement between the raters. This method, inter-rater consistency, is used for writing samples, which are obviously subjective, projective tests, which are certainly subjective, and for behavioral observation, as well as other purposes. Now clearly, since you're involving not only clients or participants who are taking an assessment, but you're also involving people to act as raters, you're going to increase the probability of error, because now you have error that could occur as a result of participants and as a result of raters. So to reduce error using this method, it's recommended to provide very detailed and precise training to the raters and have the raters work independently. There's an effect that occurs when raters are aware of each other's rating. They tend to rate in a more similar fashion, which of course you don't want. You want them to work independently and to make their decisions independently. So that was reliability. Now we're going to take a look at validity. Validity is when an instrument measures what it was intended to measure. Validity is accuracy, and there's multiple types of validity. So in order for an instrument to be valid, it has to be reliable. But an instrument can be reliable without being valid. Let's take a look at some of the types of validity. Now I'm going to start with a type of validity that's not even really a true form of validity. It's called face validity. It's when an instrument looks like it measures what it was designed to measure. So you may be asking, why am I reviewing a type of validity that's not actually a true form of validity? Well, because it is useful. Inasmuch as clients will not respond accurately oftentimes without face validity. So if a client is given an instrument that's supposed to measure depression, and maybe it does measure depression, but it doesn't appear face valid, meaning the items that they're looking at don't seem to have anything to do with depression, the client may lose motivation and start answering randomly or more inaccurately. So face validity does have a value, but it's important to remember it's not actually a true form of validity. Moving on to content validity. Now, content validity is a true form of validity. It's when an instrument's items are a representative sample of the larger content domain. So you're trying to measure a content domain, and what you want is the items on your instrument to be a good sample of that larger content, of that larger domain. Typically, this type of validity is associated with achievement tests. Now, content validity is determined by subject matter experts. So they actually look at the different items and they decide if those items are representative of that larger domain. So moving on to criterion validity. Now this is different than content validity. This is when an instrument's scores are substantially related to a criterion in the real world. So this would not be decided in terms of looking at items and having subject matter experts review items. This is where there's two forms of this. So in concurrent validity, this is where an instrument highly correlates with the criterion or a well-established instrument, and the two measures occur at the same time. So if you developed a test that is supposed to measure intelligence, and you administer your test of intelligence along with a Wechsler, which is a well-established instrument that has high validity and of course high reliability, that would be a demonstration or an attempt to demonstrate concurrent validity. Now, predictive validity is similar. It's the same as concurrent validity, but one measure is administered first and is intended to predict a criterion in the future. So, small difference between them, it's important to understand that difference. And then we look at construct validity. Now, when we use the word validity, this is what we think of most of the time. This is really the most important type of validity. This is when an instrument measures a hypothetical construct, right? Like intelligence or depression. Right? So what is intelligence? Well, it's hard to define. It's abstract. Depression, a little easier to define, but still an abstract concept. So the degree to which an instrument measures a hypothetical construct, it has construct validity. Constructs such as intelligence and depression cannot be directly observed. So determining construct validity requires using several methods. One method would be looking at the differences between groups. So for example, say we're looking at depression, And we know we have a group that experts or individuals that are close to being experts agree all the members of this group are depressed, right? We have another group, and experts or people similar to experts tend to agree these people are not depressed. And there's a lot of different ways you can try to figure this out, not just having experts agree, but there's they could have taken different measures to be placed in those groups. They could self-identify as being depressed, and your instrument, if it has construct validity, would be able to distinguish between the two groups. There should be a difference in scores if one group is appears to be depressed and one group appears not to be. Another method is experimental research. So you manipulate variables in an effort to change the value of a dependent variable. So you manipulate independent variables in an effort to change the value of a dependent variable. And this is a way where you can work toward determining construct validity. Another concept is convergent and discriminant validity. So convergent validity is when an instrument highly correlates with measures that are designed to measure the same construct. And conversely, discriminant validity is where a measure has a low correlation with measures that do not measure the same construct. So these are a few ways that construct validity is measured. So to sum up, it's important to recognize the difference between reliability and validity. And I mentioned this earlier, but it's worth repeating. An instrument can be reliable but not valid. But in order for an instrument to be valid, it has to be reliable. So reliability has to come first. So valid instruments are always reliable, but reliable instruments are not always valid. I want to thank you for watching my video. As always, if you have any questions or concerns, feel free to contact me and I'll be happy to assist you.